So much sparser map, we can't really see what's going on. And actually it clusters in strange places, which is not because the south of England is particularly bad or around Hampshire, but because they happen to have a testing center near there. And this is some of the dangers of looking at maps without all the information. And this is the map that we like because this is based on this loss of sense of smell. We think this is probably giving us the best picture of what, if we had proper virus testing, we would be seeing. So what's next? Really, we want to get to 5 million. We think we've done pretty well with 2 million with zero help from the government, the NHS, any large charities, any large organizations at all. And so any influencers out there in the audience, please, if you think this is a good idea, do help, retweet it, spread the word. Get your company to send out emails to their employees, etc. Tell you to download the app, and also the website. We've set up a special website, covid.join.zoe, where all our data is put up every day. The maps are put up every day, so you can look at it. You can interact with the research as well. And finally, really want to thank, this is a massive team effort. I happen to be the spokesman, but a lot of people have lost a lot of sleep. But I tell you, it's a really feel-good enterprise to go from the depths of depression in lockdown, everything shutting down, to feel you're actually fighting back and doing some good. So I want to thank everybody who's been involved. And hopefully I've left some time for questions. Thank you very much.
Great, thank you, Tim. Does anybody have some questions? Maybe we'll wait a little bit on the Facebook group to see if anybody pops up. I'd be most interested how the launch is happening in the US. I think you guys announced a few days ago that you were going live there as well. Can you tell us a bit about the plans there?
Yeah, so we launched about 2 days ago there. And this was with colleagues in Mass General. What they wanted to do is to send it to about 100,000 US nurses in the Nurses Health Study who might be at particular risk at the moment, and get them to do it. And there's also a large cancer charity that was backing this called Stand Up to Cancer. We haven't had as much traction on social media there as we did in the UK. And it just could be that the US is a bit more fragmented, and it could be that it needs more local rather than national type of movements, things that there isn't the equivalent of the NHS to stand behind and look after in the same way. But listen, it's early days, and things can happen. It just needs one Stephen Fry in the US to tweet about it, and maybe it could still take off. And there's no doubt the US needs this even more than the UK does, because I don't think it's got a clue what's going on there or what's going to hit it in about 3 or 4 weeks' time.
And so you mentioned that you found a couple of new symptoms that might be early-ish indicators. Are there any kind of patterns that you might see between kind of mild overall cases and stronger cases as it relates to some of these more non-traditional symptoms like loss of taste and smell?
We're still working that out, because obviously what we need to have is enough people who've gone to hospital with very severe disease to actually work out what the best predictor algorithm is for severe disease, as well as just having the disease at all. So at the moment, we've got really good data for mild, moderate disease in young people in the population, what defines it. And and actually the government will probably, and the health service will probably update reasons for self-isolating based on our finding of loss of taste. And it could well be that it's in different age groups, that the elderly get confused and may get abdominal problems. And in the young, it might be these transient things like hoarse voice or loss of taste that may precede the other symptoms as well. We're not quite sure yet which way they all go.
And one of the areas that you do a lot of research on is on the gut microbiome. And it's been pretty clear over the last 12 or 18 months or so that the gut microbiome has been implicated in all sorts of different health conditions. Do you have any insights on how gut health can influence overall immunity and against this condition, or what people can do?
Sure. Well, we think that part of the reason that some people are getting virtually no disease and other people are getting really severe ones and ending up in intensive care is their immune systems are very different. They're programmed differently. And we know that having a good, healthy gut microbiome is crucial to have a good immune system, a balanced one that doesn't overreact and yet doesn't underreact. And to do that, you need to have a diverse set of microbes and certain keystone species that we're finding out. And we're running this other study, the PREDICT study, which was in a way the day job of my team and ZOE trying to predict nutrition. And we're finding out that a lot of bugs are associated with inflammation or immunity. And so coming out of this, probably in a few months' time, we will be able to say what type of microbes in your gut are the best to protect you against future epidemics. But there's definitely a link. It's quite obviously complex because the one thing, everyone is completely different in their gut microbes. Even identical twins have very different gut microbes. So that could be the reason we react differently to things like these viruses. I think that's a really exciting area in the future that we'll be looking at, because we've got no clue about this bug. We have to really keep a very open mind about what's driving it and why it can kill some young people, and most are completely spared. In the dark.
And Tim, just given the community we have at London.AI, everything from practitioners, students, academics, teams working at rather large companies, how can the community help you? What's the best way? Is it resources you're looking to join your team, volunteers? How can we best help?
Well, the first thing is to spread the word and see if you can get some influencers to increase the numbers, particularly more elderly, anyone over 60 really, help them to download the app, point them to it, or even log people in themselves. We're ZOE, I'm sure, would like some extra skilled machine learning people, or people who can engineer quickly fixes to the app, if there are any people. But I think the main thing at the moment is keeping the momentum going, so that we can keep doing media stories and to give something new, and that means growing the base of volunteers so they are interested, and we can give them a story so they're actually logging in every day, because it's that longitudinal part of the data that's important. So far we have about 7 million entry points. So on average, people have been logging in about 3.5 days per person, but I think some are dropping off because they might be losing interest, and that'd be a pity. So I think it's mainly spreading the word how amazing this is, and using it yourselves and sharing it with other people is the biggest thing we can do at the moment.
And a question from Shannon Lowe. How applicable is this approach to early mass diagnosis of other diseases besides COVID-19? And if so, what kind of disease is it most applicable to?
That's a great question. I think it could well be for common diseases that people aren't really, don't have a lot of knowledge about. And there are a lot of ones in the population, like irritable bowel syndrome, for example, or generalized chronic fatigue syndrome. These ones that doctors aren't really sure what they are, which are the real symptoms. And so if you had 1 million people reporting daily on them, you could use machine learning to really tease apart the fact they might be 4 separate diseases. So I think it's anything that's really common, that has a variety of ways of showing up. And I think we're going to need these skills, because this definitely isn't going to be the last pandemic we have. And we need a much better toolbox to deal with it. And it's obvious that no governments have been ready with any apps or tools to collect this information. And so hopefully this will be a great warning system really for the future. But I think it does have application in many other things that you can only really measure quickly by self-report. And psychiatry is another one, because there's no easy test other than asking people. And so coming up with a whole range of symptoms, putting into machine learning, working out what makes sense and how much you weight of different factors, I think is really crucial here.
And just to elaborate on this, I think you mentioned this, but some users are asking, do you only want users from the UK? I think the answer is no. And just elaborate on the geography.
Just to be clear, that if you do the search on COVID symptom tracker in the UK, you'll get the UK download. If you do that in the US, you'll get the US download. We're talking to other countries, but we can't actually cope at the moment. And there's a lot of African countries and developing countries that really need it, but we need funds to do that. We're just so stretched at the moment keeping up. But you think about some of those places in Africa are never going to have screening. They really need something like this, because most of them do have mobile phones in their villages to know what's hitting them. But it does need some philanthropy to come in and help out there, if there's anyone who's interested in those developing countries. But it's certainly feasible, because everything's going to be open source. It's all not for profit. We want to share it widely. The data is just going out anonymized to all researchers as soon as it can.
All right. And just a bit more on the technical side, we have a question from Millie Zhao asking if you could dive into some of the machine learning methods you used for this study.
No is the answer. I haven't had a chance to talk to the guys who have been actually doing it, but I'm sure you could ask the guys at ZOE. It's all pretty straightforward at the moment. Most of it has been linear models, sticking things together. To do it quickly, that's been the first approach, and then it'd be more detailed machine learning with prior weightings and things that might be of clinical importance. So at the moment, it's just too early. Remember, this data is only about 2 days old, so we're not doing anything sophisticated at the moment.
Great.
Awesome. Well, thanks so much, Tim. I know you've got some more stuff to do this evening. You're a very busy man, so appreciate you taking the time to share with us. We got about 150 people who joined in for that, so thanks again.
Okay, my pleasure. Good night, everyone.
See ya. Awesome. So from nutrition and science and COVID, we're going to switch over to dialogue systems and speech. So next up, I'd like to welcome Nikola, who's the co-founder and CEO of a London-based business called PolyAI, developing state-of-the-art conversational systems for large-scale enterprises around the world. So with that, I'd like to shoot it over to you, Nikola. I think you can share your screen whenever you're ready.
Will do. Hi, everyone. Thank you, Nathan, and thank you for inviting me to speak. Hopefully you can all see my screen here. And okay,
all good.
So, yeah, thank you for having me. And tonight I'd like to tell you a bit about my company, PolyAI, and how we are using conversational AI to build next generation solutions for customer service. And before we kind of like kick off, just a bit about the company. We were founded 3 years ago. We are a spin-out from the University of Cambridge, from Steve Young's Dialogue Systems group there, where I met my co-founders and most of our senior research team. Since then, we kind of dispersed. I was the first employee at VocalIQ, a company acquired by Apple in 2015. So I spent 2 years at Siri. My co-founders and the senior team worked at Google, Facebook, Microsoft. Some of them built Google's Smart Reply and a few other kind of like large, wide-scale deployed machine learning systems that quite a few people love and use these days. And we came back together to really try to make an impact on voice-based dialogue systems. And I'll give a bit of background to about the way we see the world and the way we see dialogue and what can be built with conversational AI and why we don't think it's actually advancing at the speed that it should be. since 2017, we raised 2 investment rounds from Amadeus Capital, Passion, Point72, and you can see some of the logos of the companies that we are working with right now on the right. But if you think about conversational AI, right, and you think about things like Siri and Alexa, they've become signature names of popular culture, right? Around 40% of American homes right now already own an Alexa device, right? And if you think about the size of these organizations, they're humongous. Alexa has anywhere between 12 to 14,000 people working to build the product. And it's a good product, it's loved by many, but it feels a bit disproportionate. And similarly, Google and Apple have thousands of people working on these things. And when you look at the ROI on actually deploying these systems, you might think and wonder whether there is actually a positive ROI. And the truth is, to a lot of people, it feels like these personal assistants are something like the modern day version of aircraft carriers in a Cold War between these big tech companies that really serve to show off their technical capabilities, their machine learning capabilities, and everything that they can do, rather than something that is a core part of their business. But then when you look at the wider space, there are companies like IBM, Nuance, Interactions, and there are a bunch of these do-it-yourself tools for building chatbots, right? And back in 2016, we had a huge surge in chatbots, and we thought that all customer service would soon happen over WhatsApp, over text messages, and that we'd stop calling, and that these companies really banked on companies themselves developing their solutions using the technology that they push on top of their cloud infrastructure. However, it turns out that these, in the end, become quite expensive tools for people, and that despite all that, we still have 2% of the British population working in customer service. And we've got 6 million people in America working in customer service. And it's huge, right? And it's here to stay. These are service-based economies where the footprint of customer service estates for big enterprises is only going to grow. And the truth is that even in this new age where we are more and more technically literate and we have more and more ways of accessing technology, people still prefer speaking over the phone, right? And if text as a communication channel was as effective, we would actually probably just have this meetup over an email group. And yet we like to talk to each other. We like to ask questions. We like to interrupt each other. We like voice. We like talking, right? We've evolved to talk and to be very good at, especially expressing a lot of information with our voice. And this, regardless of the age group, people like using the phone. They like calling, and increasingly for big brands, especially in service areas where the offerings are commoditized, customer service is the one big differentiator which decides the success of these big companies. And I've been in this area for a while, and the truth is that 5 years ago, if you tried to pitch an automated voice-based solution, so not a chatbot, but something that is a replacement effectively for a customer service representative, they wouldn't really think that it's possible. But I think that we're lucky in that with the overinvestment by the big tech companies, people are willing to believe that we can build voice-based solutions that in the end will actually improve the customer experience over a traditional call center. And especially when you look at it today with COVID-19, a lot of these call centers are struggling. They've been closed down because of the social distancing measures. And even companies as big as 3 are actually unable to put anyone on the other end of the line. So if you think about the fact that there are 14,000 people working for Amazon, for Alexa, to make it work as well as it does, and it's still far from the ideal personal assistant that we'd all like to have in our homes, there are 2 fundamental technical problems that limit both kind of like the scalability and the applicability of these systems. The first one is natural language understanding itself. And under the hood, most of these systems have thousands of natural language understanding models that are built to recognize things called intents, basically things that you might express. Like you might say that you want to book a table, or you're trying to get a replacement for your vacuum cleaner. And when you try to model a longer conversation, something that's a bit more complicated than a single turn command, the combinatorial explosion and the thing that you see on the right really hits you hard. And it means that you can't actually predict every way that a conversation can go. And that's why you have to build thousands of these models, you have to maintain them. And the more of them you have, the harder it gets. The second, the more insidious problem is that of designing the dialogue policy. And that's really about drawing this graph that you see on the right, kind of like predicting everything that a user might ask and deciding what the best thing to do is. And every time that your customer service procedures change, you actually have to update this tool. And a lot of the current kind of like approach to building chatbots and conversational agents in general has gone towards the hope that it can be commoditized, that it can be given to software engineers that will use these graphical user interfaces to draw these graphs out. The problem is they get really big and really complicated. At some point, they're really hard to visualize. And at that point, you need 14,000 people to support something that effectively plays music, sets alarms, and occasionally, but very rarely, allows you to purchase something from Amazon. So when we started PolyAI, and we've been working on this for a long time, long before Siri was a thing, before Alexa was a thing, we started thinking about a different approach, a machine learning approach that would move away from building these thousands of natural language understanding models and going towards a single system that would be akin, for example, to a Google search engine, something that is a single model that at every point in the conversation, looking at the number of possible things that it could say, chooses the best answer based on everything that had transpired in the conversation up to that point. And ideally, if this same model could be trained on a lot of data, and in the spirit of deep learning, it could be pre-trained on a lot more data that may be slightly out of domain. And again, in the spirit of deep learning and being a data-driven fanatic, you might want it to work across all domains and across different languages at the same time. And that's the beauty of deep learning. It actually provides you with a framework where if you design the neural net structures right, you can do something like this. And we call this approach that we developed over the past 3 years content programming. And it really kind of like moves away from trying to get a software engineer quickly up and running as a proficient designer of dialogue systems, and instead says, hey, you know your application domain. You know what it is that a customer service representative might want to say at a given point in time. And in reality, when you look at the problem and the thing that we're trying to address, it's that the churn in contact centers can be up to 200% a year. And that means that they change their entire workforce 2 times a year. And that's quite shocking for any of us working in tech companies or pretty much in any traditional industry. And it's gone so far that a lot of the times when a new customer service representative in a call center is onboarded, they're not even trained anymore. They're just given this PDF or a stack of papers where there are a bunch of answers to questions that customers might ask. Now, they have to do this quickly, and it's a hard job. As part of kind of like learning about the area, we tried doing it. And I kid you not, this is one of the hardest things I ever tried doing, because someone's calling you and they're angry, they're upset, and they blame you, right? And it's not your fault. You're just a customer service representative that maybe started working 3 days ago, and you're looking at these 10 A4 pages and trying to find the best response. And you stumble upon something, you're like, okay, what about this? And you read it out. And the truth is, if you had a machine learning model that looked at what had happened in the conversation so far, and maybe it had been pre-trained on a bunch of conversations, it would actually be equally good at finding out that answer and giving it back to the user. And this is what we call content programming, because we believe that it's not right to ask software engineers at these big enterprises to become experts at building dialogue systems. We think that what they do well is they understand their business processes. They need to give us these answers, and at that point, our models should be able to pick the best answer. So if you think about a simple application, something that's very, say, Siri-like, you might be in front of a pub. And you might say, hey, I'd like to grab dinner. I'm in front of a pub called the Flying Pig. It's an excellent pub in Cambridge. I wholeheartedly recommend a visit when the coronavirus crisis is over. And you might ask, when is their happy hour? Which is quite a random question. And in the traditional world of building virtual assistants, you would actually have to build an intent that says, request happy hour. And then you'd have to program a response. But our system would just basically look at everything that's available and say, they have a happy hour between 5 and 7 p.m. And this might be something that someone in a review had written. So the user might continue and say, that today's daily food special is the rodeo burger, which is again something that the owner might supply to the system on a daily basis. And the owner does not have to be a proficient chatbot developer. All they have to do is update their metadata on their website, and our model could support this interaction without actually having to know anything specific about the flying pig. And this model we call the encoder, and it's I won't go into detail, but it's a dual encoder that looks at kind of like the best answer that fits the a good conversational flow for any specific interaction. It's pre-trained on things like Reddit, Twitter, Quora, and it needs very little data to achieve very high performance. And if you, here we have a benchmark of the encoder, especially in low data regimes. And this is important because a lot of the time, you're asking people who are deploying these systems to give you extra data so that your system can perform a bit better. And if you train a machine learning model, you know that the key is to get a wide coverage of different kinds of data points that you're able to, examples of things that people might say. And especially in low data regimes, our pre-trained model can actually outperform all of the other ones by quite a big margin. And when you add more data, this advantage perseveres, although it does reduce quite a bit. But in practice, what this means is that we're able to build systems for companies very quickly, and we're able to get systems that work a lot better than anything that they would be able to build with existing tools. So just to quickly go through some of the things that we've managed to deploy so far, and really we spent the first year and a half of our company's existence building the product, and we've been deploying it live only over the past 8 months. So here in this one, we managed to beat Microsoft, Amazon, and Google, who were pitching kind of like a hybrid professional services and a DIY tool to this company. And we're very happy to win this one because, we are a pretty small startup, and getting to a point where they choose us over them meant that, they believe that this thing can actually do a lot better than what their internal IT could build with help of consultants using the tools that are out there. But the more exciting one, and our first big enterprise deal, was with a large British hospitality company, which owns 2 big groups of restaurants here in the UK. And their problem was that they were missing 30% of the calls that would go to their restaurants, but because people tend to call mostly when the front of house staff is busiest. And that means that they were missing 30% of all calls. And that meant that they were losing quite a few of the bookings and people coming in and a lot of revenue. So we deployed a virtual assistant that takes reservations for them. And kind of like without going into much detail, we were able to increase their booking conversion rates by 33%. And this amounted to about 6 to 7 million of additional revenue. Now, obviously, given COVID-19, these guys are taking a break and not running right now, but we look forward to them coming back online and the system taking even more calls. But kind of like to wrap up, I'd love to play you a recording of a real customer, someone who probably never interacted with Siri or Alexa, just to illustrate why voice is so difficult and why building voice-based conversational agents really takes a lot more than building chatbots that are typically something that very technically savvy people interact with.
This call may be recorded for quality and training purposes. Beefy to the crossbush. I'm a digital host. How can I help?
Oh, are you there? Oh, are you real or digital? Do I have to book?
I am a digital host. I can make bookings and answer questions.
Oh, I'd like to book a table this evening for 6:30. For 4 people, 3 to 4. I think I'm hoping for 4 people. About 6:30 today. Under
Okay,
Sarah.
I'll check for 4 people today. What time would you like to book for?
6:30.
Hang on a second. Let me check. Great, we have a table today at 6:30 p.m. for 4 people. Should we get that booked in for you?
Yes, please.
Can I take your
yes,
full name
please.
for the booking?
Sarah.
We cut this part out for preserving privacy.
Can we reach you on this number?
Yes.
One sec, I'm just making sure that went through. Okay, that's all sorted. You can hang up or let me know if you have any other questions.
Thank you. Bye-bye.
You are most welcome. Is there any other question I can answer for you?
Do you have to book before arriving every day, or can you just turn up a different day and hope for the best?
We recommend booking so you can be guaranteed a table.
Okay, that's great. Thank you, that's all. Thank you.
So that's an example, and you kind of see the challenges of answering questions that may not make full sense, but you still kind of have to say something that is meaningful. But on that note, I see that I might have overrun slightly with my presentation, so I'm happy to take any questions, and thank you for your attention.
Thanks, Nikola. Do you have any questions?
I kind of have to say something.
Alice, can you see any questions on the?
Yeah, 1 second, just moving between windows.
I kind of have to say something.
Yeah, so no, not seeing a question yet, but just on my side, we've seen quite a few use cases in this space, as you mentioned, everything from IBM Watson to Alexa to Siri over the past few years. But what are some of the industries that, from your sales experience a few years ago, would have said absolutely no to a conversational dialogue bot? Obviously, hospitality and those are some of the early adopters, but over the past few years, you've seen companies you never thought would join this and now are more open to this.
Absolutely. I think that, hospitality actually isn't a typical example of an early adopter, at least for this kind of things. So I think when we came in with this thing, it really was all about a managed service where they just wanted to deploy, don't want any involvement from their IT team. They want nothing to do with it, right? If you look at kind of like financial services, they were the early adopters, and there's been a lot of good stuff happening there. Utility companies, especially in the UK, are now more and more interested in deploying this kind of stuff because they've had the price freeze for a few years now. They're bleeding money like there's no tomorrow. And, they'd be willing to consider something that they wouldn't really even look at maybe 2 years ago.
Got it. And just for relevancy, any COVID lockdown healthcare related use cases being explored right now?
Absolutely. We've already had, it's not health based. We've been speaking with a few people at the NHS, and we'd love to help because we can do a lot, both for kind of like, appointment making, for test distribution. Any one of these scenarios is something that is kind of like, right in the center of what we'd love to do. We've had a lot of inquiries from call centers that are no longer able to, have their workforce working from their offices. And the truth is, not many call centers are fully set up for remote work, because the big contact center software providers know how much money, call centers can save by not renting huge premises. So it's actually been quite expensive and difficult for traditional, contact center software companies to sell these remote working packages to call centers. Now, they don't have it deployed, which means that now they can't actually take calls remotely. They can maybe help their customers out through email and through chat, but they can't do it with voice. So we've had a surge of demand from customers asking for, kind of like any kind of like voice-based automation that can help them at least with some of the customer queries, because half of the call centers have key workers, right? Say, telcos for internet providers, they still have part of their call centers coming in because they're essential for the, what's left of the economy functioning. But, if you look at something like retail delivery or fashion, their call centers have been slammed shut. So there's a lot we can do.
Got it. And we actually got quite a few questions, so we'll try to filter through them. But one from Renata Koster, asking how much model training and work do you need for your model to be applicable to another industry? Example, how much easier would it be to apply your product to another restaurant chain versus another industry entirely?
Yeah, no, I mean, the beauty of this model is that it's actually really easy to deploy across domains and across the language. So for another restaurant group, we could deploy this in 2 days, right? For another hospitality scenario, it would be a week. And for anything else that is even mildly related, maybe 2 to 3 weeks. And often the main kind of like blocker there would be like the technical integration with the reservation book. And in that call, you might have noticed that we say, hang on a minute, let me check, right? And that's not something that you should be doing if the response is immediate. But if it's not, then you have to add those kinds of fillers. So sometimes making sure that you dance around the integration in the right way so that you're able then to provide an experience where people don't just hang up, that's what can take some time. But yeah, in terms of the machine learning itself, that is the part where we spend the least amount of time optimizing.
We have a question around if you use any or have considered any symbolic approaches, like having a large-scale knowledge graph of some generic structure.
That is a question that can be interpreted in many different ways.
There's no more context than that. It's from Danny Belinko, so maybe he'll work right back.
Let me say some stuff that I think may be relevant, and then I encourage the person who asked the question to just get directly in touch, and I can talk, all night long. In terms of kind of like symbolic approaches and kind of like things that are not your traditional mindless data-driven machine learning that's been popular over the last few years, we actually, when we designed the dialogue policy, that's a really sophisticated piece of, computer science, right? Where, we've got typing theory involved. We've got data flow formalisms for dictating how the flow of the policy can go. So to avoid, someone drawing out 1,000 different ways that a conversation can go, you write rules that dictate what you might want to say. And they can be probabilistic. Maybe a few of them fire, and then you might pick one randomly. But it's actually a really, really complicated problem. And to say that machine learning is the panacea, that, the silver bullet that will just blow out the problem of designing conversational agents, that's not true. We need a lot of good computer science. And, symbolic approaches, depending on what the person who asked the question means, have a lot to give, right? Not even just symbolic approaches to AI, but overall, good old traditional computer science. The problem is far from cracked.
I have a question on what happens if somebody gets angry on the call. Like, how can you deal with emotional escalation?
Yes, absolutely. So it does happen, and your heart shreds into 1,000 tiny pieces when it does. And we listen to a lot of these calls because we try to improve as fast as we can. And you can detect emotion, and that's another signal and trigger to hand off to a human agent. So Nathan knows, for example, our trajectory, and we considered buying a contact center just because we believe that the challenge of really doing this systematically is really, really difficult, right? And the key thing to do if you really don't want to agitate the caller is if it goes badly, if it goes really badly, and it will, because this technology is not yet perfect, you need to hand off to a human, and you need to know exactly when to hand off. It might be, a signal that comes from the emotional disarray of the person calling because your system really isn't doing it for them. Or it might be just because they're really angry to begin with. And sometimes people call centers and they're shockingly rude to those staff. So, it's incredible actually the level of patience and the emotional intelligence and effort that call center workers put in. They're the unsung heroes of our society.
True that. Maybe the last question is, what have been some of the challenges and opportunities that that you've seen on managed service use cases?
Yeah, well, I mean, when you look at the kind of like different companies that we sell into, there are companies that just want a fully managed service approach where they want to get on the call with a deployment strategist from PolyAI and, weekly calls, updates, dashboards. That works, but it involves a pretty substantial professional services piece of PolyAI that we may end up growing, but we're not particularly keen to grow the company in that direction. To a lot of other customers, they like to mix and match. They might use speech recognition from Google, and then they might use the PolyAI stack to deploy the initial sophisticated agent, but then they would really like to be able to edit it themselves because they don't know what happens to us. They don't know how responsive it will be. They've invested a lot internally into teams that are able to do a lot of this themselves. And there you have to be flexible around how open your framework is. And we don't have a full answer to that question just yet. We're kind of like hovering around a managed services approach where the key lines of kind of like use cases are open to the client so they can edit and deploy. But there's a fundamental trade-off there between trying to have something simple like, say, Google's dialog flow, where you just draw out the dialog flows and then do whatever you want, but you can't do much. And the alternative is there's a managed service by PolyAI. It's a black box to a large extent because it's very complicated. And we've not been able to distill it into something that anyone can use. And not to say that the people at Google are any less smart than my guys. Google is an incredible company. This is just a really hard challenge. It's going to take 5 to 10 years before we're able to fully commoditize this ability to onboard someone who's not spent years doing it and turn them into someone who can build respectable conversational technology.
Mm-hmm. Yeah, awesome, cool. So I think we can continue maybe the discussion on AMA afterwards. Thank you again, Nikola, for taking us through that. So I will now just tell you a little bit about more context about the meetup and what we're trying to achieve here. So just share my screen. So as Alex mentioned at the start, I'm Nathan and I run the meetup with Alex, and really what we're trying to do is build a really kind of engaged community that can share best practices, knowledge and opportunities around applied machine learning across lots of different industries. And one of the main tenets that we have is that everything, all the money that we make through the event is basically funding a nonprofit initiative. So we don't make any money off of these events, but we use all of the capital in order to fund education and research all in the open source for AI that meets common good objectives. And so far we funded quite a few fellows to work on OpenMind, doing privacy preserving machine learning. It's a community that's entirely open source that companies can draw from. And we've also funded Open Climate Fix to do much of the same, but working on climate problems. And so, so every in-person meetup that we run, the funds get donated to the RAAIS Foundation and to these initiatives. And we encourage you, if you want to chip in a few pounds, to go at raais.org/donate. We very recently, given the context of this pandemic that we're facing around the world, we launched a RAAIS COVID-19 Relief Fellowship program where we're taking up to $5,000 and donating in the form of grants to organizations, individual researchers, and healthcare practitioners, no matter where they are in the world, who can effectively put that capital to use to try and help us all fight this condition. And so this is an open call to proposals. So if you have ideas of what you might want to do with this amount of money in the open source, we encourage you to come and apply. It's a simple email. So you can find more details at raais.org/COVID. So apart from like 1 or 2 glitches with using Facebook, just as a note to self, don't use the beta features of a new viewer. It doesn't work. It's not stable. We're going to run one of these events every 2 to 4 weeks online. And so if you'd like to give a talk, please don't hesitate to ping either Alex or I whenever you'd like. And we look forward to joining us again on this Facebook group every 2 to 4 weeks. And then in a couple of months' time, we'll have our annual RAAIS conference, which will also be online. And so if you'd like to learn more about that, please head over to RAAIS.co. And finally, if you want to hear more about future events, please just drop your email on London.AI. We have a newsletter there that's solely used to give you alerts about future events. And you can follow us on this Facebook group and also on Twitter. So with that, I'd love to introduce Helen, who's a field AI engineer at Graphcore, which is a novel semiconductor company building chips for AI. So we'll stop my sharing and over to you, Helen, if you're able to jump on.
Hi. Let me share my screen. Hey. Can you hear me okay?
Yep.
Great. Sweet. Cool. Does that share in the normal?
Yep, this one works.
Yeah, it's not in the word presenter mode.
Yep, it looks good.
Cool. Great. Thank you. Cool. Thank you. Thanks everyone for sticking around to hear my talk as well. I'll try and stick to 15 minutes. I have a few equations in my slides, which I'll try to not dwell on too much. There's a bit of technical info, but hopefully it's interesting as well. So just who am I? I'm Helen. I work at Graphcore. I'm a former research engineer. So the topic of my talk today is about the Graphcore research directions for this year. I actually moved in the last month to the field team, so I'm now actually working in a more sort of customer-facing, customer applications-based role. But I have been in the research team for the past 1.5 years. So I want to talk to you about, firstly, who are we at Graphcore, because it kind of gives you some context around our research. Then a quick whistle-stop tour of our research subject main projects. I can only really get into detail on a couple of those. And thirdly, my research work that was based or is based around distributed learning for large-scale machines. So Graphcore. This is a picture of our chip, our C2 card, which contains 2 chips. So yes, as Nathan said, we are a semiconductor company. We have designed a new processor, a new chip for AI, for machine intelligence. So why was that needed? I'm sure many of you have seen a slide like this before. This is taken from an OpenAI blog from a couple of years ago now. So you can see here the scale is logarithmic. There's this massive increase in model size, in the time taken to train these AI models, and it's only continuing. So maybe we need to design a processor, a new chip that's specifically built for these applications. So up until now, we've been using processors that were designed for other applications. We have CPUs. They were designed for applications to browse the web, to send emails. GPUs were designed for graphics and also for use in HPC. So the IPU is our chip. It's designed from the ground up specifically for artificial intelligence workloads. And hopefully most of you know who this guy is. So when asked in a Wired interview last year to Jeff Hinton, the legend himself, said, we need to move towards a new type of computer. He happened to pull out a Graphcore IPU chip, which he had in his pocket, which he had been given by one of our founders when they had met at Mrkšić. And he says we need something new to build and to train these new machine learning systems of the future. They need to think more like a brain, and they need to be different to the processing power that we have at the moment. Incidentally, he works for a large company which has their own processing chips, the TPU. And I won't go into too much detail because I've only got 15 minutes and I need to get onto the research. But this is a sort of overview, a schematic of what the chip looks like. I'm going to just quickly go over the kind of two of the main design, significant design fundamentals of the chip. So the chip is made up of 1,216 IPU tiles, and each tile is made up of this IPU core of compute coupled with memory. So what this means is all of our memory is actually on our chip. It's in distributed SRAM, whereas with other hardware, most other hardware, you have it in the DRAM. And what that means is we completely reduce the latency of any kind of data transfer. Our model is held on the chip, our knowledge graph, our weights, our activations, they're all held on the chip. So we eliminate the communication cost, and this gives us a huge speed up. And concurrently with that, each tile has its own core, and each of these cores has 6 threads, and they're completely independent. What that means is we can use the IPU in a much more kind of flexible way. You don't need to have to vectorize your operations. You can do many different independent processes, or 7,000, in fact, over 7,000 in parallel. So that's just a quick overview. You can access IPUs if you want to have a go at using them. There's 3 providers that you can use them via. The details are on our website, and if you want to learn more, go into more detail, you can obviously ask me later on, but go to our website. There's a load of information on there. The blog's pretty good, pretty up to date with the latest information. So Graphcore research. So the Graphcore research team focuses on fundamental machine intelligence research. So I guess what we've been hearing about so far tonight is very much in the application space, which is hugely exciting and fascinating, and we hope that IPUs will be used for these applications. The in-house research team focuses on fundamental research at the moment, so application sort of agnostic, hopefully, and we're looking at the problems from a perspective where we're not driven by legacy hardware. So we're not limited to design models to a certain hardware. To a certain legacy hardware. We've got this new flexibility, how can we use it? And the other kind of direction or objective of the team is to stay at the forefront of the cutting edge of research, because we need to know what workloads and what is required by the latest research, the latest models, what's required of the hardware. This is a summary of the main projects that we are working on at Graphcore. There's others around there, but these are sort of the main ones. I'm going to just touch on a few of these. So arithmetic efficiency. This is really looking at what precision do we need to have in our training and inference of our models. So but by default, neural networks tend to use this float 32 number representation. You can see what it looks like on there, the bit representation, the sign bits, exponent bits, mantissa bits. Don't know, you don't have to know too much about this, but that's sort of the default representation that's used. And we're really looking at how can we use lower precision formats. If we use lower precision formats, we are able to reduce our memory footprint. So we can hold models with larger numbers of parameters. We have less memory of activations also, and we're reducing our compute. We can do more flops. So it's quite an important area of research. I'll just show you a couple of results from looking at doing this investigation. We look at the forwards and the backwards pass arithmetic separate to the weight update arithmetic. I can just show you why. This is just showing you a kind of baseline result of running ResNet 32, CFAR 100. The details aren't too important. You can see if we run everything float 32, the forward backward arithmetic and the weight update arithmetic, that's our baseline performance. If we run the forward and backward pass arithmetic in float 16 with the weight update in float 32, we meet the same convergence with no degradation. However, if we put our weight update into float 16 as well, then we see this degradation. So we've still got a good reduction in memory and a good increase in flops with using the 16 and 32. But how can we get the weight update down to float 16 as well and save on the memory of the weights? So just looking a bit closer as into why we have this issue with the weight update. This is just the kind of your SGD weight update equation. And on the right, you see represented as bits. So we have this parameter, you'll have your parameter vector, which is shown at the bottom on the right. And it's generally a much larger number in magnitude compared to your update. Your update is your gradients scaled by eta, your learning rate, which we know is often a tiny number. So with float 32, we can add these two numbers together. However, when we reduce the precision to float 16, we actually don't have now enough precision, enough range to add a large and a small number together. And we just end up with these kind of zero updates, which is where we get that degradation in convergence. This is a fast lesson in stochastic rounding for those of you who aren't familiar and don't use it. It's something that's implemented into our chip. So it's important when we do a lot of low precision arithmetic. And I'll just show you why, just in this simple example. If you are adding 0.3 to 0 100 times, and we round that, we round 0.3 and we do round to nearest, then we end up with adding 0 100 times onto 0, and we end up with 0. So stochastic rounding means that now it's non-deterministic, and we're rounding up and down with a probability that's proportional to our residual bits. So what that means is if we're rounding 0.3, we have a 70% chance of rounding it down to 0 because it's proportional to our 0.3, and we have a 30% chance of rounding it up. And this is important when we're doing lots and lots of low precision arithmetic. So what we get now is we're adding 1 30 times, and we're adding 0 70 times of our 100, and we end up with 30 as our final answer. And that's what we get as well if we didn't round at all. So you can see how stochastic rounding helps in these situations where we're doing a lot of repeated arithmetic. And this is the same, just showing you with the bits representations. And just to see what that looks like, now if we run the same model, but now we use float 16 for our weight update as well, but we use stochastic rounding. Now we completely get back the precision, the convergence and degradation that was lost from just using the float 16 formats with the round to nearest. So this is just some of the work that was done. This is sort of quite old now, I guess. The latest work, which is about to go up on archive, is into custom 8-bit floats and showing that they can be used for weights and gradients activations, for image classification, and also for language models. Sparse structures. So sparse training is really important. Why is that? So this is just showing another one of those exponential graphs, but this was there was a model released in February by Microsoft this year, which is the largest model ever published with 17 billion parameters. So the models are just getting crazy big, and it's really not sustainable. We can't carry on forever like this. We know as well that trained neural network models tend to have a very low percentage of the weights that are actually non-zero. So we end up with a very sparse trained over-parameterized model. These over-parameterized models, though, are easier to train, and they often generalize better. But we know as well that the brain is made up of 150 trillion parameters, and we know that it's very sparsely activated. So this is something that's really interesting, and we need to find a solution really to this sparse training if the models are going to carry on growing at this speed. So the story of sparsity starts with pruning. So pruning is where we train our model, and then we prune off certain parameters according to their magnitude. So the smallest magnitude we prune away. And intuitively, we think that they won't impact our output, our performance, if we are pruning away the smallest magnitude, because they have the least effect. This works quite well. It only really gives you a benefit in inference, because you still have to train your model. It's also unstructured, and what this means is it's actually hard to see any efficiency gains other than in the memory. It's hard to see actual training efficiency, computation efficiency gains. So this is the way that the research is moving, and the way that we are moving in our Graphcore research. There was a paper last year called Rigging the Lottery. And this is a way of dynamically training a model and sparsifying it as it's trained. So in this way, you don't have to pre-train the model in full. It's trained for a certain number of epochs, then it's pruned, sparsified, then it's randomly, the weights are initialized again and continually trained. And the results are quite good. So this is a really interesting area of research, and certainly something that Graphcore is interested in. So finally, I wanted to talk to you about distributed learning in large-scale machines. So what are the problems with distributed learning? So firstly, we have this problem of communication becoming a bottleneck. So we want to add extra process nodes. We want to increase the number of processors. So we're increasing the batch size, we're running data parallel, and we want to speed up our training time. However, we see this issue where you can see from this plot that I've stolen from someone else, that you see the point between 16 and 32 processors, where actually the time that it takes to train the model is now going up. And that's because the communication between the processors has now become the bottleneck, and it's taking too long. So we have this problem with communication. But even if we had no problem with communication costs, if we could scale up forever and it was no issue, we still reach the saturation point with usable mini batch size. So these plots are from some work from Google from nearly 2 years ago as well. They basically show for all image classification, for all language model results that they tested lots of different models, lots of different data sets, lots of different optimizers. And they found in every case that there was this initial period, initial scaling, where you increase your batch size, you reduce your training time, but actually this starts to peter off, and you get no benefit from increasing your batch size in terms of the number of steps that it takes to reach your desired loss. So these are the issues with distributed learning. We can look at them, we can approach reducing the communication in a few different ways. How often do you communicate? this is just, the graphic is just displaying to you a kind of conventional SGD, synchronous SGD. The W's are the workers on the left, or the different processes. They do an SGD step, they exchange their weights or their gradients, they do an SGD step. That's our basic conventional approach. Local SGD, it's called by a few other names as well, is where the workers actually do a few steps, a few local steps before exchanging the weights between them, before synchronizing. And this is quite good because it reduces the communication by that number of steps. However, we encountered this problem in neural network training. We're dealing with non-convex optimization. We might have two different models, and they found they've found a low error on the loss surface. However, when we average the model parameters together, we don't necessarily end up in a low loss area. We see this issue. So what about who you communicate with? If we have many processing nodes all communicating, maybe it's too much, maybe it's overkill. Why don't we just communicate with a subset of them? So some of the work that's been done in our team is communicating with just neighboring processes. So is it more communication efficient? Actually, it turns out it's not, because there's a really efficient communication algorithm called ring or reduce, which I'm sure many of you know, and it's super efficient. And it actually means that even if we're only communicating with our neighbors, and we're not communicating all to all of the processes, that it's still not as efficient as ring or reduce. If assuming if we have less than or equal to 2, the number of neighbors is less than or equal to 2 for each worker. So that means that each processor is connected to less than or equal to 2. Then the ring or reduce is actually more efficient. So this doesn't really help us with communication efficiency. And it turns out it doesn't actually perform better anyway. These plots are just showing a degradation in terms of performance if we are connected more sparsely in our topology. So what do you communicate? So this is in the focus of my work previously. Instead of sharing parameters, instead of sharing gradients, why don't we try and share something else? So this is based off some work called co-distillation. It's in the work, basically you have n networks, and you're now encouraging each network to predict the other networks to have the same predictions for the data. So you add a loss penalty to each worker's loss function, and you're saying you're encouraging them to predict the same classes. And that's just so we use the KL divergence, which is just what that equation is there. And then in our work, the extension to this was to introduce a hyperparameter for this co-distillation loss, this distillation loss. What that means is we could control how much the co-distillation was influencing the total loss throughout training. And we were able to derive it automatically online as part of the model's optimization. This work will hopefully be available on arXiv soon, but this is the kind of high level summary of what that looks like. And the results meant that we could train many networks, and we could actually improve the performance versus an ensemble of networks. However, with an ensemble of networks, you have to use, at test time, you have to use all of the networks together. So say you have 4 networks and you train them in ensemble, you need 4 networks to run at test time. With this method that I've just been talking about, we were able to match that performance, but you only have to take 1 model at test time because each of the models achieve the same performance. This on the right is also showing that you can use these models co-distilling together, and you can beat a model which has the same or larger number of parameters. So it's kind of inspired to to use many smaller networks instead of using one larger network. Yeah, there's lots of information here, so hopefully it's not too much. So it's much more communication efficient because we're not sharing weights and gradients. And as we're not sharing our weights and gradients, we kind of avoid this mini batch size growing problem that I talked about earlier. So yeah, in summary, for distributed learning, there's many different approaches. We find that actually using a few of them together works quite well. And it's really essential work because all models are growing and they need to be split up and run over many devices. So how best to do that is a really important question. So yeah, thanks to some of my collaborators, and also we are hiring at Graphcore. So please go to the website if anyone is interested in doing any work in our company. We're always looking for some good people. So thank you. Email me if you want to follow up about any of that later as well.
Awesome, thank you, Helen.
Sorry if I overrun.
No, it's good to have some evening maths. So
yeah, I know, right at the end, it's not the best.
Oh, you maintained everybody's attention. We have a few questions, and we have a bravo, Helen. So a question on pruning, which is, how do you determine the magnitude? So is it based on some sort of feature importance check?
So that is something that's like a hyperparameter that you can choose and define. The obvious way to do it, the easiest way, the original way that it was done 20 years ago, or whenever it was done, was by magnitude. So just by the size. So you prune away the smallest weights.
Okay. And then what kinds of what kinds of data types have you worked with and done benchmarks on? Like what does the chip work best with?
Yeah, so we have some really interesting benchmark blogs on our website. That's probably quite interesting to this audience in terms of it's a bit more application based as well. Because I was presenting my work, it was less applications based. But yeah, so we have some benchmarks on our website. So the IPU works really well with, so let's say traditionally models that don't run super efficiently on current hardware, where they require data to be vectorized, where you have to fill these dense arrays to get the full efficiency. So when I was talking about the design, we have this flexibility that means we can run these iterative models, MCMC, time series, RNNs. We run them at the same efficiency. We don't have to vectorize anything, so they work really well. We have some benchmarks for ResNext. So in ResNext, it doesn't run quite so efficiently on current hardware. You have these smaller group dimension group convolutions. They run very efficiently on IPUs. We are able to train BERT, which was designed for TPUs and runs very efficiently on GPUs. We're able to train BERT with the same training time as a GPU, and it's much better suited in terms of the design to that hardware, but with a 20% less power consumption, and at inference we're much faster. Because, yeah.
Awesome.
So there's if you want to look at more of the benchmarks, there are quite a lot on our on the blogs on our website, and there'll be more coming out soon as well.
Great. And just as a note, we've added the job section to Graphcore on the comments, so you can check it out there. Helen, just a question for you. Out of all the use cases you're seeing, now that you're in a more customer-focused role, out of all the use cases that you're seeing coming out of industry, what are the ones that excite you the most, where Graphcore can really make a difference?
So I guess that's just like, what are the kind of coolest applications where I think that the innovations are the most important. So healthcare, I think there's some really interesting work going on in some of the startups and the companies we're speaking to in the UK, in terms of like genome sequencing and drug discovery. It's a lot of the healthcare applications are obviously super interesting, and you know, it's important. Obviously, hearing from Tim earlier, anything that can help towards the COVID pandemic, obviously that's something that we would be really excited for researchers to be able to use the IPU and do something different that maybe they are restricted by with other hardware. But we are speaking to lots of different industries. So we have some investors that are car makers. Therefore, we certainly are looking at the applications for AVs. Yeah, I mean, healthcare is obviously the most important, I think.
Have you found any best practices for like effectively crafting a research agenda and making it really efficient to go from new R&D into actual product improvements?
So product improvements in terms of, so I guess for us, our research is very much just to be cutting edge, and the research kind of feeding back into the product improvement. For us, for our product, is this what everyone wants to do, and how efficiently can we run this? So I guess that feedback loop is slightly different. I think in terms of a research project, we spend quite a lot of time reading papers on arXiv and attending the big conferences, and speaking to kind of collaborators at academic institutions and where we can. And we are like excited by kind of the areas that I've listed, but really ways to look at how do we continue to grow these models, but run them efficiently to reduce the power consumption and all of the kind of areas that tie into that. And a lot of the starting points of our projects are finding really, really good research work that exists already and just running that, and how do we actually get the same results, and then going from there of how can we improve it, and what works and what doesn't. That's kind of the cycle, I guess.
And one of the themes that seems to be quite hot in the research segment, and there's some few startups working on, is auto ML. So like trying to automatically design neural network architectures. Have you, as a business, done any research there? And do you have any thoughts on that, especially when you have a chip that's super powerful and can maybe solve this?
Yeah, so I think that's a really interesting area. We have one of our research projects that I didn't go into detail about is on neural architecture search. And yes, it's quite exciting to be working within a company where we have access to some brand new hardware that hasn't like been played around with yet, and how can we actually design models that will really efficiently run on this hardware, and what innovations can we come up with from that? So neural architecture search and AutoML is definitely something that we're really interested in and working on in-house as well.
Cool. I guess last question we have, last question we have is around open source. Do you guys have any open source projects that you're looking for contributors on?
Do you know what? I'm not sure what it's changing sort of day to day dynamically with that. So we open sourced all of our software docs last week. And we are starting to partner up with some institutions and some, we've had a couple of papers that have been accepted at conferences where they've been academic papers, but with a Graphcore collaborator. So we are sort of starting small, but yes, that in terms of collaborations and open source projects, it's as we grow, and yes, that's something that we'll definitely go as much further into and do as much as we can. It's just scaling up is our kind of only limitation, I guess, at the moment, is the number of people that we have to support all of that. But if anyone is interested, they can sign up on our website to stay in touch and get the latest news, and that everything will be posted there.
Great. Well, Helen, thanks again for a wonderful presentation, and as Nathan said, a bit of evening math to keep us on
sorry about
our
that.
toes. No, that's great. It's a huge virtual round of applause for that. Well, thanks to Tim, Nikola, and Helen again for 3 amazing presentations. As Nathan said, we're going to try to do this every 2 to 4 weeks. And yeah, I think the best way of staying in touch, if you haven't done so yet, is to follow us on Twitter, join the Facebook group, and check out our newsletter, which is at London.AI. We'll keep you posted as to what we do next. We might try a different format, so worth following us somewhere outside of just Facebook. I think just given that Tim had to leave because he's going to do an interview with the BBC, and that it's actually getting a bit late and our speakers might want to get dinner now. What we might do is we might just post how to get in touch with the speakers, likely your Twitter profiles. And if you have any questions, you can just follow up from there. As mentioned, we're also doing this to raise money for the RAAIS Foundation's COVID efforts. So there's a link in the URL. We're making these events for free. And if you had a good time, feel free to make a small donation. Everything counts. And yeah, we hope to see you again in 2-4 weeks. Stay safe, stay indoors if you can. And yeah, have a good one and enjoy your dinner, everyone. Thanks. Bye.
Thanks, everyone.
Bye. Thank you for having us.